Hey guys, so for this video we're going to be looking at different types of solutions for intersecting lines. And there are three possibilities that you may encounter. So if you follow through this activity using Desmos, you've already seen the three different scenarios. The first one being the one we've been working with all along, where two lines cross and they have one solution or one point of intersection. So for the first portion of this task, you should have gotten one solution for each question. Moving on to the next page, you should have noticed that these lines do not cross one another, meaning that they are parallel lines, and each of them would then have zero solutions or no solutions. And for the final one, you may have not known what to write here, but when you graph these two line segments, what happens is they are actually the exact same line. So one lays right on top of the other, so we say that it has infinite number of solutions. Basically, every point on that line is touching the other line. So moving on, you should have completed this table by copying your different equations of lines into this chart. If you want to pause it here just to do a quick check that you put the right ones in the right place, feel free to do so, but we're going to scroll down and answer the questions at the bottom. So first off, line A, how can you tell by looking at an equation in y equals mx plus b form that there is one solution? And the answer is that their slopes are different. Whether or not their y-intercepts are different doesn't matter. You can see with the second example we did, they had the same y-intercept, but they still had a point of intersection, and it has to do with those slopes being different values. Part B, how can you tell by looking at the equation in ax plus by plus c, equals c form that there is one solution? And it's that the ratio of the a's is different than the ratio of the b's. And I'm going to talk about that a little more when we get down to D, and you'll see what I'm talking about. Part C, how can you tell by looking at the equation in slope-intercept form that there is no solution? Well, to have no solution, the lines must be parallel. And we know from previous lessons that lines that are parallel have the same slope. So slopes that are different, one point of intersection, slopes that are the same will create parallel lines. How can you tell by looking at the equation in ax plus by equals c form that there is no solution? And this is where the ratios of the a's and b's are the same, but the ratios of the c's are not. So I'm going to scroll up to an example here so you can see what it is that we're referring to. So to calculate the ratios of those a and b values, the a's are the numbers in front of our x's. So in this case, negative 2 over 6. If we reduce that to lowest terms, we get negative 1/3. Do the same for those b values, the number in front of your y, or the coefficient, and we get the same ratio, negative 1/3, negative 1/3. Negative 8 over 15, though, will not give us negative 1/3, and that's how we know we have one solution. Another way you could maybe quickly see it is if you're just multiplying this by negative 3, and you multiply the next one by negative 3. So you might easily see a common number that'll show you that they have the same proportion. Okay. Same with this one down here, double this number, but the third one is not doubled. But either way, you can do that ratio and see. Over here, 2 over 4 reduces to 1/2. Negative 5 over negative 6 reduces to positive 5/6. So they don't have that common ratio piece. Moving down to the last one, how can you tell by looking at the equation in this form that there are infinitely many solutions? In other words, the equations are exactly the same. And that would be the ratios of the a's, the b's, and the c's are the same. So you can see the difference here. Double this number, double this value, and double this value. So those c values also have that relationship. In this case, negative 3 times gets us to each additional number. So finally, moving on to how this would look for us algebraically. So if we were to solve this equation algebraically, let's see what would happen. So I'm going to choose to solve this by elimination. I'm going to double that top equation. So I would get 6x minus 4y equals 16. Because I have positive 6 in front of both, I'm going to now subtract those two equations. So negative 4 minus negative 4, like adding 4. So I get 0y, which of course is 0. And negative 4 minus negative 16 is negative 20. So what ends up happening here is I lose my variable. It eliminates itself. When I subtract here, I actually eliminated my x's. I had that 0x. I eliminated my y's. We've eliminated both of them and we get this uneven equation here. This tells us that the lines are parallel and there is no solution. For the next one, we can solve this equation as well. I'll also solve this one by elimination. So I'm going to triple that top one, giving me a negative 3x and positive 6y equals 9. Because I have opposite signs here, I'm able to add the equations together. So that will give me 0x when I add these, and I also get 0y on the opposite side. And on the right-hand side, negative 9 and positive 9 also gives me 0. So what ends up happening here is I do have this balanced equation of 0 equals 0, but I'm stuck and I can't solve this any further. What that indicates to me is that these two equations are exactly the same, and I have an infinite number of solutions. So when you end up with a 0, 0 here, infinite solutions, whereas when you end up with eliminating both variables, but they're not equal, 0, 0, we have no solution. And that is the end of your video for today.